Hi guys, this is section 7.3, which is solving systems of linear equations by elimination or linear combo. Okay, our textbook calls it elimination because you're going to eliminate one variable, but the high school textbook calls it linear combination or linear combo. I just wanted to make it clear so that in case you get to high school and they call it linear combo, you know that that's the same thing you already learned. Okay, when we're solving, there's three ways to solve it: graphing, which was 7.1, substitution, which is 7.2, and elimination or linear combo, which is 7.3. Okay, there's three parts to solving by elimination. Number one, you want to line them up and eliminate one variable, solve for the remaining variable, and then solve for the variable that you already eliminated. Make sure you get coordinate forms. You want an X and a Y answer because that's how it's going to work. Okay. The question is when to use substitution or elimination. Okay, for substitution, if they give it to you like this, where they give it to you in slope-intercept forms, or they solved one of the variables, so it's y equals, that's pretty easy. You can substitute because you can just take this equation, or I'm sorry, this 3x plus 1, and put it into this y of this equation. Okay, or in this case, if they give it to you as x is equal to 2y plus 5, you can just take this and then put it into the, or substitute it in to the other x. So if they make it easy for you in this case, the way they write the equations, go ahead and use substitution. But if they give two equations in standard form like this, where you cannot just substitute a number in, this is where you want to use linear combo or elimination. Okay, so you can line them up and I'll show you how to do that. The first thing you want to do, we got a few different ways. This first one is the easiest. Line it up, line up your x's, your y's, and your constants. So put it in standard form. In this case, it really doesn't matter whether a, the 5 or the 3, is positive or negative because we're going to eliminate one of them anyway. What we're going to do is we're going to just add up the columns. Add up your x's, add your y's, and add your numbers. So if you look at this, I can already see that negative 6y plus y is going to become 0. There, I eliminated one variable. Remember over here when I said first thing you want to do is eliminate one variable. Okay, so over here you can say eliminate one variable, and now I'm just going to add down what I have left. So 5x plus 3x is going to be 8x is equal to, and this is negative 32, so it's going to be 16. Oops, sorry. I'm going to divide both sides by 8, and I'm going to get x is equal to 2. And if you remember, I need coordinates, so I need to take this 2 and put it into either one of these equations. I'm just going to choose this first one because it's a smaller x, and plus it's a positive 48. Again, it doesn't matter, you're going to get the same answer. So I'm going to get 3 times 2 plus 6y is equal to 48. This becomes 6, so I'm going to minus 6 from both sides. Oh, actually, I'll just show it to you. I don't want to skip steps. 6 plus 6y is equal to 48. Minus 6 from both sides, and I get 6y is equal to 42. Divide by 6, and y is equal to 7. So my answer is going to be 2 comma 7. Okay, and that's how you do linear combo. So again, the easiest way is when they line it up, you can just eliminate one variable right away. That makes it easy for you. Here's a little trick here. I have a couple examples here for you. So in the first one, you can see I lined them up. And I cannot eliminate either of the variables right off the bat. Okay, you can see I have 2x and 10x and then 5y plus 3y. That doesn't work. So what you want to do in this case is look at the a's and the b's and see which ones are either factors of each other or multiples of each other. So I can see 2 and 10, and I color coded it for you. I can just multiply this by 5 and I get 10. That's pretty easy. Whereas the 5 and the 3, I can't multiply by a certain integer to get rid of it. So I want to eliminate my x's because it's going to be easy. And if you remember, we need to add the x's. So I need one of them, like if you notice in this equation, one was negative 6y and one was positive 6y, so that it became 0. So in this here, I want one of them to be positive and one of them to be negative. And since I have the 10x already as positive, I can just multiply this equation by a negative 5. And I'm going to cheat and do this way, but make sure you do this third rainbow. Okay? So when I do that, I get negative 10x minus 25y is equal to positive 110. So this equation just became this equation. And now when I look at these two equations, I can get rid of that. And I can put the line here. I can see that my x's get eliminated. That becomes 0. And now I can just add my y's, and I get negative 22y is equal to 132. Okay. When I divide by negative 22, I get y is equal to negative 6. Okay. Now I can take this y and put it into either one of these equations. It doesn't matter. I probably want to go to one of the first two since it's smaller numbers, because this one got bigger because I multiplied by 5. So I'm going to take this y and I'm going to put it into, let's just go into this one for fun. And I get 10x plus 3 times negative 6 is equal to 22. This becomes 10x plus negative 18 is equal to 22, or just minus. When I plus 18 to both sides, this gets gone, eliminated, and I get 10x is equal to 40. Divide both sides by 10, and x equals to 4. So my answer is going to be 4, comma, negative 6. Again, make sure you, make sure you find that coordinates for your answer. Okay. Here's my other example. So you can see I left the gap in it, but the first thing you want to do, if you remember, was line it up into standard form. Okay. So what I need to do is minus 5x from both sides. And I'm going to get negative 5x minus 2y is equal to negative 14. And now I have my two equations lined up in standard form. And if you look, I have a negative 5 and a 3, so I cannot combine those yet or eliminate that. But I have a negative 2 and a 6. So that's the one I want to eliminate. In this case, I want to eliminate the y's. Okay. So what I want to do is multiply this one by 3 so that I get a negative 6y, because I want, since I have a positive 6y, I want a negative 6y here so that they eliminate. Okay, so 3 times negative 5x is negative 15x minus 6y, and then minus equals negative 42. Okay. And there is my two equations now. So now I have these two equations. I can eliminate my y's, which is good, and deal with the x's. So now when I deal with my x's, I'm going to get negative 12x is equal to negative 48. And you can go from there and solve it for x. So homework check number 1 is solve this problem, this above problem, by elimination. So sorry, I know it's hard to see. So homework check number 1, solve the above problem by elimination. And there it is for you. Okay, you can hit pause and copy that down if you want. Here's where it gets a little more difficult. When you look at this example here, the 4 and the 7, they are not multiples or factors of each other, and neither is 2 and 3. So now I need to multiply both equations. I'm sorry, I didn't point it out in this one. In this one, you can see I multiply just one equation. So in this case, I multiplied the top one, and in this case, I multiplied the top one again. In this case here, you're going to have to multiply both equations to get elimination. So it doesn't matter which one you eliminate, the x's or the y's. Because I have a plus and a minus and I have small numbers, I'm going to go after my y's. Okay. So if I do that, I need to multiply this one by a 3 to get 6y, because I want this one to be 6y. And then I want this one to be a negative 6y. So I'm going to multiply this one by a 2, so I get a negative 6y. So this one is going to go here, and this one is going to go here. Okay, so when I multiply by 3 this way, I'm going to get 12x plus 6y is equal to 42. And I can see it's going to run out of room. And this one I'm going to get 14x minus 6y is equal to negative 16. Okay. And now you can see I eliminate my y's. If you didn't get it, don't worry. I'm going to try to do one more example for you. Okay, now I just add them all up. So I'm going to get 26x is equal to, and I'm going to subtract that and get 26. Divide by 26, x equals 1. I'm going to take this and put it into any one of these four equations. Again, I would use one of the first two because they're smaller numbers, you can see, because I multiplied these to get bigger. So I'm just going to go into the first equation. Let's just go into the first one. So 4 times 1, which is just 4, plus 2y is equal to 14. When I minus my 4 from both sides, I get 2y is equal to 10. Divide by 2, and y is going to equal to 5. So my answer is going to be 1 comma 5. Okay, so that's how you do that one. Here's another quick example. I know it's getting a little long. So I have the 3 and the 5 for the x, the 5 and the 7 for y. So I know one of them I need to multiply by a negative number in order to eliminate. So I'm going to go after, in this case, since I got rid of the y's, I'm going to get rid of the x's in this one. Again, it doesn't matter, but I'm just going to do it that way. So I need to multiply both equations. This one needs to be by the negative 5 because there's a 5 here, and this one by the 3 there. Okay, so you can get a negative 15x on the top, positive 15x on the bottom. If you wanted to do negative 3 there and positive 5 there, you can. Doesn't matter, again, either way. Okay, so I'm going to distribute this, and I'm going to get 15x plus 25y is equal to 50. And I'm going to distribute this bottom one, and I'm going to get negative 15x minus 21y is equal to negative 30. Okay, so you can see this is eliminated. I eliminated my x, so now I can solve for y's. So I get 4y is equal to 20. Divide by 4, y is equal to 5. Put this into any one of these equations. I'm going to go for the smaller numbers. 3x plus 5 times 7 is equal to 10. 3x plus 35 is equal to 10. Wait. Oh, I'm sorry, this should have been a 5. That's where I went wrong. So this should be a 25. I'm going to minus 25 from both sides, and I get 3x is equal to negative 15. Divide by 3, x is equal to negative 5. So my answer is going to be negative 5 comma 5. Okay, that's how you do elimination. So you can see it is a little laborious. There is some work to do, but it's better than going and graphing them and looking for all that. Okay, the last part. Writing and solving equations, systems of equations from real world examples. So I'll kind of pull in close so you can read it a little better. So they sold 292 concert tickets. Adults are $3, students are $1. They collected $470 total in ticket sales. How many of each ticket was sold? So how many adults, how many students? So you need to write two equations. The first one is always going to be just for the number of tickets. So if we say A equals adults and S is equal to students. A equals adults and S is equal to students. Okay, we're defining our variables. The first equation is just A plus S is equal to 292. That is just the total. The second one is going to be value to it. So if adults is 3, I would say 3A plus students is just 1S is equal to 470. And if you want to put the dollars to see that that's where it came from, that's fine. Okay, so you can see one is just the number of tickets and one is the value. Now we need to linear combo them. I can just multiply this by a negative 1 to get rid of the S's or the A's, either one. Oh, I'm sorry, the S's in this case. So I would get negative 1A minus 1S is equal to negative 292. Okay, and you can see my S's got eliminated. When I solve this, I get 2A is equal to 8. Oh my gosh. 108. No, sorry. Let's put an 8 here, 9, 6. 168. No, 178. Sorry. Divide by 2. And A is equal to 89 tickets. I take this, and I can put them into either one of them. So let's just go into this one since it's either. So I get 89 plus S is equal to 292. I'm going to minus 89 from both sides. And I'm going to get S is equal to 203 tickets. So you can see, in this case, you don't need to put them into coordinate form because it's in a word problem. So there's 89 adult tickets and 203 student tickets, and if I add them together, I should get 292, and that works out good. Okay, so I just want to set up one more for you guys, and this is what it looked like. Now Pio was having a car wash for their trip. They were charging $4 for cars and trucks, $10 for SUVs and vans. They sold 205 pre-sale tickets and collected a total of $1,084. How many of each was sold? So how many cars and truck tickets and how many SUV and van tickets did they pre-sale? Okay, again, first one is number. So if let's just call this one C for cars and trucks. And we'll call S for SUVs and vans. Okay. It would just be C plus S is equal to the number of tickets was 205. So there's a number. That's the easy one. And now we need to do value. So cars is $4 for each. So it'd be $4 for cars plus $10 for SUVs and van is equal to 1,084. Okay, so you can see how that is set up. Actually, I'll do one for you. So I'll minus 4. I'm going to multiply to get rid of my C's. So I'm going to get negative 4C minus 4S is equal to negative 820. Okay, and now I have my two equations here. So this one became this one. And I'm going to eliminate. And I'm going to get 6S is equal to 264. And you need to divide by 6. Divide by 6. And S is equal to, and I'm going to let you do the rest. So homework check number 2 is solve the above problem by elimination. So here's your two equations. I did it all the way up to S, so you need to find S, and then you need to go back and find C's for cars and trucks. Okay, that is the lesson. Hope this helps.